Good morning, students. Welcome to your Wednesday lesson. Here we are. We're going to be looking at solving one-step equations today, and this is going to be a great build-off of what we've been working on. You just did a lot of work here with the 5D process, so we are going to revisit solving one-step equations in advance of solving those equations that we've created with the 5D process, which is what chapter 6 is going to be focusing on here for us in CPM. So, solving one-step equations, let's take a look at what we have. When you're taking a look at a one-step equation, what that really means is that you have a variable and one operation happening with that variable, and then from there it's equal to a number. So in our first one here, for example, x plus 8 equals 27, there's that one operation happening. So when you're looking at solving these one-step equations, really what you're doing is you're going to be doing the inverse operation or the opposite operation from what is being done to the variable in order to solve. So if we take a look at that very first one here, we have x plus 8 equals 27. So you identify, where's my variable, what's happening to it? We have 8 being added on to x. So that x plus 8 there. So with that, we need to eliminate the plus 8 part. So in order to do that, we're going to use the inverse operation of addition. The inverse operation of addition is subtraction. So we're going to go ahead and subtract 8 because that's what's being added on to the 8. And when you do this, be sure to do this to each side of the equation. So we're going to subtract 8 from each side. We do that because if you think of an equation like a scale, like a balancing scale that you might use in science class, one of those that if you put something on the left side, in order to keep it balanced, you have to put the same thing on the right side. And that's what we do here with these equations. Anything we do to our left side of the equation, we have to do to the right side of our equation. So here we subtract 8, and the idea is to, when we're adding and subtracting, to make 0. This plus 8 and this minus 8, those make a big 0. So all we're left with on our left side is just x, and that's going to be equal to 27 minus 8 here, which is 19. So that first one here, we have 19. We take a look at our second one. We have x minus 13 equals 42. And identify where your variable is, what's happening to it. We have x minus 13. So we are subtracting 13. We're going to use that inverse operation idea here with this one. And we are going to go ahead and, because we're subtracting, the opposite or inverse of subtracting is addition. So we're going to add 13. And again, make sure that you add that 13 to both sides of your equation. Keep that equation balanced. Whatever you do to the left, you do to the right. And again, with subtraction here, the idea is to make 0. So we have that x minus 13. Now we're going to add on 13. So we get that 0 idea here. And all we're left with is x. And that is going to be equal to 55 here. 42 plus 13 giving us that 55. So solving for x, we get x equals 55 here. All right, our third one, we're going to change it up just a little bit. Now we're going to look at multiplication. So identify our variable here. What's happening? We have 5x. So when we have a number next to a variable without any operation in between, that is multiplication. There's an invisible multiplication sign going on there. So really what that's saying is 5 times x equals 70. So in order to solve that, we need to use our inverse operation here. Our inverse operation of multiplication is division. So we're going to divide by that number that's being multiplied on. So we're going to divide by 5 on each side. And when we go through and do that, the idea here with multiplication, it's a little bit different. We're trying to make 1 now when we're using multiplication or division. And that's what we did here with that 5 over 5 idea, that 5 divided by 5. Any number divided by itself gives us 1. So really what that's saying is we have 1x left or just x. and that is going to be equal to 70 divided by 5, again, because we're doing it on both sides, which is 14. So we get x equals 14 for this. Our next set we want to look at, I have two different ones here that both represent division, because we'll see division in a couple different ways. We can see it with the division sign here, such as number 4, or we can see it set up as a fraction like we have in number 5. So if we take a look at number 4 first, we have x divided by 4 equals 11. So with that, we identify where our variable is, what operation is happening, and we need to do the inverse operation. So here we are dividing by 4, so in order to eliminate dividing by 4, we have to multiply by 4. So multiply by 4 and multiply by 4, and we are going to get that one idea here on the left side. So we are left with just x is going to be equal to 11 times 4, which is 44. What's really nice, I haven't mentioned this yet, is we can check this. We can easily check this by taking the value that we get for our solution. So we got x equals 44, and we can substitute it back into x for the original equation. So if we did that here on the side, I'm going to do that. I'm going to put 44 back in for x, and we have, so that gives us 44 divided by 4, and when you divide 44 by 4, you get 11, and you should get an equation that matches when you do the check. All right, our last one, again, it looks a little bit different because we have a fraction setup. We have x over 6, x our numerator, 6 our denominator, but really remember a fraction is just division. So in order to undo division, we're going to use the inverse operation of division again, which is multiplication. So on this one here, we have x divided by 6. So we're going to go ahead and multiply by 6, multiply by 6, on each side. So multiplying by 6 on each side, and we're going to get that one idea on the left side here because we have 6 divided by 6 really is what's happening. So that's going to leave us with just x, and that is going to be equal to 8 times 6, which is 48. So the big thing to remember is when you have the variable left with just one operation, you go ahead and you do that inverse operation or the opposite operation from what is being done to the variable in order to solve for it. This will be a concept that you are going to be using for the rest of the time that you take math classes. Solving for variables is a very foundational skill that is going to be needed for a long time for you. So getting the practice in today, getting the practice in moving forward and into chapter 6 is only going to benefit you. I hope this helped, and if you have any questions, let your teacher know, and we will see you later.